Hello, my name is Chance Bingen. I'm a Senior Technical Marketing Engineer for Virtualization at NetApp. Here we are again at Lake Betts on the NetApp campus in Research Triangle Park, North Carolina. I haven't done a lakeside video in a while, so I figured we were long overdue. Hopefully you've seen some of my lakeside videos before, and if you haven't, just search for NetApp with Tanzu videos and they'll be on the top of the results. But today, I'm excited to announce that the ONTAP Tools 9.10 VASA provider now has the ability to import vVols from unmanaged volumes. This new capability was designed specifically for use with NetApp SnapCenter to allow it to back up and restore vVols-based VMs, as well as use SnapMirror and other NetApp technologies to manage data. But it doesn't just stop with SnapCenter. You can absolutely write your own code to back up, replicate, and import vVols using your own automation tools, taking advantage of the new REST APIs. ONTAP Tools now empowers you to deliver new custom-tailored storage services for enterprise applications through your own private cloud with expanded options for backup and recovery, replication, even disaster recovery. You can even combine them with SnapCenter using the SnapCenter plugin for VMware's own REST APIs. Of course, we also still support VMware Site Recovery Manager with both vVols and traditional storage, so you can take advantage of that option as well. This is kind of a big deal because traditionally this has been, a common workflow for old school NAS or SAN storage. But with vVols, it's a different animal because the VASA provider that makes vVols possible must be able to understand the nature of a vVol in a very deep way to enable all the goodness that comes with storage policy-based management. With that said, what I'd like to show you today is a short demo of importing a vVol from a SnapMirror replica and attaching it to an existing VM so that the guest OS user can recover files from it. Now, in my case, I am using SnapCenter to create and replicate the snapshots, but you can obviously code that on your own as well, or like I said, integrate SnapCenter into your private cloud using its REST APIs as well. So, as usual, let's head back inside, log into the lab, and see how this works. Starting off at the vCenter home screen, we'll go confirm our test VM has the correct tag assigned. You can see I created a custom tag category for SnapCenter and assigned a tag called Backup Daily. Jumping over to resource groups in SnapCenter, you can see I created one called Tag RG. And when we click on it and look at the top right, we can see the Backup Daily tag. If we go over to Policies, we can see the policy we've selected for the backup job, and we can see that we are updating SnapVault with the backup. In the interest of time, I've already cloned the volume from a SnapMirror replica. And now, there are lots of examples on the internet of doing that, so there's no need to cover it here. Okay, this is my vVols data store. This one is NFS, but it could be SAN as well. This is the VM we're going to use, Clone Workstation. You can see all of its files, and we can see that it is the only VM on the data store in this case. Of course, it wouldn't be like that in production, but that's okay for today. Here we can see that vCenter shows it has two VMDKs attached, one for the OS and one for data. And if we jump over to the PowerShell ISE, you can see the name I've defined for the temp data store I'm going to create. And throughout, I'm going to use the same name for the Flex clone and its data store to make things easy. Hopping over to ONTAP System Manager, we can see the Flex clone volume. I've defined variables for the VM name and SVM name. And here you can see where I defined the vVols data store to create using the Flex clone. This is converted to JSON and used with the invoke-rest method commandlet. Next, let's look at the syntax to import a vVol. Here, using the new temp data store, we are in essence creating the VMDK descriptor file of a data vVol type, which points to the actual vVol data file referenced by the new UUID I generated previously in the script. And if we look back, here's where I generated a new random UUID based on the original UUID for hard drive 1 on the VM. If we look into the guest OS, we can see the OS drive and the data drive, which is disk 1 as mentioned previously. Okay, so let's go ahead and run the script. This is the session I have authenticated with using vSphere authentication, and we'll be using it for most of the work. And you can see this has generated task ID number 11. I built a pause into the script so we can go and take a look at the task status. If we go over to the ONTAP Tools Swagger UI, we can authenticate with that session ID and check on task ID 11. And we can see it's running. Okay, and now it's completed. And we can see the vVols container details, like the backing FlexVol, for example. We'll say yes and let it continue until the next pause that I built in for the demonstration. We'll go over to vCenter and confirm that, yes, the data store is created. So we'll say yes. Next, the script adds a folder to store the VMDK file in. Then we go through the UUID rename and import the vVol and add it to the VM. So let's go back and see how it looks. First, we can see that the new data store has files for the correct VM registered to it. And if we look at the files, we can see the folder we created and the VMDK in it. And if we jump on into the Windows Guest OS, we can see the disk is there. We can online it and it gets a drive letter. We can now recover our files using whatever method the Guest OS administrator wants to use. I hope you enjoyed that demo. If you have any questions or comments, please post them in the accompanying blog post or feel free to contact your NetApp account team, NetApp authorized partner, or your partner SE. You can also reach out to me directly on Twitter at CB8MyDataCenter with the number 8. See you next time.